Alright, in this video we're going to look at finding the surface of revolution. So we have here y equals 1/3 x cubed, and then we have the surface area formula 2 pi integral from a to b, r of x, which is going to be is your radius, and that's going to be the distance of your function to the graph. And the axis of revolution, so we're looking at rotating around the x-axis, and then you have the square root of 1 plus y prime squared, and that's like your arc length. So it's kind of like your circumference times your arc length here, 2 pi r being the circumference of a circle times your arc length, but the radius is variable, and so what we need here is, of course, we need the derivative to be continuous so that we can integrate. And so we'll go ahead and take the derivative here. So y prime is going to be x squared. So specifically, our surface of revolution, surface area of revolution is 2 pi integral from 0 to 3. And then our radius function is 1/3 x cubed, and that's the distance between the function, the graph, and the axis of revolution, which most of the time is just going to be your function. And in this case, it's the y equals 1/3 x cubed. And then the square root of 1 plus x squared dx. And again, this is set up so that we can actually evaluate this using a U-substitution. I'm going to go ahead and pull the 3 out in the denominator, and we'll go ahead and do the U-substitution. So u is going to be equal to x to the 4th plus 1. Du will be 4x cubed du. So we're going to end up dividing by 4, and so that'll knock out this 2 here, and it'll introduce another 2 down here, so you get pi over 6. Okay. So we'll get pi over 6 integral from, and I went ahead and swapped my limits also. So if we plug 0 in, you're going to get 1, and then if you plug 3 in, 3 to the 4th is 81 plus 1. So I swapped my limits when we did the U substitution. U to the 1/2 du. This is going to become pi over 9, u to the 3/2, 1 to 82. So you're going to end up dividing this by 3 over 2 when you do the power rules. So flip that over, and that'll give you 2 pi over 18, and reduce that to be pi over 9. And then just evaluate, and this surface of revolution is going to be about 259 units, and it depends on the problem how accurate you want that to be. So that's an example of finding surface of revolution.